Hi, welcome to Section 7.7 Factoring Special Cases Part 2. Today I'm going to teach you how to recognize a perfect squared trinomial. You'll hear teachers call it a PST, perfect squared trinomial. Okay, so what we're looking for here, and I'll just write down the examples here, it's easiest. First of all, we're going to look at the signs. Is it a trinomial? That's the first thing. Yes, these two are going to be trinomials. And then are the signs either plus plus or minus plus? That's the first thing. Okay, let's look at the one here on the right. Plus plus, it's a trinomial. Let's do the square root of x squared, which is x times x. The square root of 9, which is 3 times 3. Okay, you can hear me talk about this in class. You're going to squeeze these two together, which means multiply. 3x times 3 is 3x. And then you're going to double it. So 3x plus 3x, and that's going to be 6x. If that becomes that middle term, then you know it's a perfect square trinomial. And the way you're going to write your answer is going to be the first square root of the first term plus the square root of the second term, quantity squared. Now that is the same thing as writing x plus 3 times x plus 3. But this is just the cleaner version of it. So this will be your final answer right here. Okay, let's do another one now. Here on the right. If my signs are minus plus, you do the square root of the first term, the square root of the last term, but they're going to be two negatives. So it's negative 3 times negative 3, which becomes positive 9. Do the same thing. You're going to multiply these together to get negative 3x. And then you're going to double it, or times it by 2, and you get negative 6x, and you see that that is the middle term. If that's the case, you know your answer is going to be x minus 3 quantity squared, which is the same thing as x minus 3 times x minus 3. Now, this is just practice. The more you see, the easier it'll get for you. Do some problems now. The first look at your signs, plus plus, good. So square root of n is n times n. Square root of 16 is 4 times 4. If I multiply those together, I get 4n, and if I double it times 2, I get 8n. So that works. So you're going to write n plus 4 quantity squared. Now, this one, for A, you can also go back to the traditional diamond method. That works too, right? It's just kind of a shortcut for you to see that you can factor it if you recognize it. Now, doing the diamond problem on B gets to be a little bit more extensive. That's why I want you to recognize it as a perfect square trinomial. So the square root of 4x squared is 2x times 2x. Look at the signs, negative and positive, so this is going to be negative 3 times negative 3. Well, when I multiply these two together, I get negative 6x. And when I times it by 2, I get negative 12x. So you see, that's the middle term. Now I can recognize it as 2x minus 3 quantity squared. Now, again, you can do it as diamond method, like we've done, right? Multiply a and c over to get 36, and then negative 12, and then you'd have to make sure you always divide it, right? So what two numbers multiply to 36 but add to negative 12? That would be negative 6 and negative 6. Then you would reduce it, negative 2/3, right? And then you would finally get your 3x minus 2 times your, oh, sorry, I wrote that wrong. Take that back. Not 2/3, 3/2. So negative 3/2, negative 3/2. Then you would write your problem as 2x minus 3 times 2x minus 3, which is the same answer here. And if you can recognize it as a perfect square trinomial, it'll be a little bit quicker. Okay, practice problems. So, perfect square trinomial, m1, m and 1. Now look at the sign, so these are really negative 1. Yes, it works out. When I squeeze them together, I get negative 1m and negative 1m, so I get negative 2m. So this is m minus 1 quantity squared. Okay, 10. D times d, negative 5 times negative 5 because of my signs, negative 5d, I get negative 10d. So this is d minus 5 quantity squared. Again, those two you could do the normal diamond method. Number 11, it's good if you can recognize it. It's 3z and 3z, 6 and 6, multiply, oh look at the signs, it's plus. Multiply them together, 18z times 2 makes 36. So this is going to be 3z plus 6 quantity squared. You got to make sure you put your quantity squared. Now when we solve equations, that's when we want to look for our zeros. So hopefully you can recognize that as a perfect square trinomial. So it's going to be a plus 3 quantity squared equals 0. Now what number do I need to put here to make that 0? And the answer is going to be negative 3. Or you can do a baby algebra problem. A plus 3 equals 0. Subtract 3 from both sides. A is going to equal negative 3. Same thing. Look at 14. 14 is not a trinomial. Let's see if it's a dots problem. N times n, 9 times 9. It's a square, and that's a subtraction sign. So this is going to be n plus 9 times n minus 9 equals 0. Now, what numbers do I need to put here to make those zeros? It's going to be negative 9 and positive 9. So this one has one answer. The perfect square trinomial technically has two answers, but you only need to write negative 3 once.